Up until this point, we have been talking about machine learning models as if they're standalone. Yet, when we talked about real companies that use machine learning, whether it is Netmarble or AirAsia, you found that we were talking about a set of machine learning models that address a set of business needs. That's because machine learning models don't exist in isolation. You almost never build and put into production a single ML model. That's like putting into production a software library. What you put into production are applications that use the software library. And that is true of machine learning also. You will put into production applications that use machine learning, and these applications won't use just one ML model, they will use many. So an important design consideration is that you should think about how to create a seamless experience out of many models. Take Google Translate, for example. The Google Translate app lets you point a phone camera at a street sign and it translates the sign for you. This is a good example of a combination of several models that is quite intuitive. One model to find the sign, another model to read the sign, to do what is called optical character recognition on it, a third model to translate the sign, maybe a third model to detect the language, and a fourth model to translate the sign, a fifth model to superimpose the translated text on the original image, and maybe even a sixth model to select the font to use. Even a simple user journey will involve multiple machine learning models. These are so ubiquitous that you probably don't even notice them anymore. I'll walk you through a familiar use case so that you develop the eye to recognize machine learning models being put together into a use case. You will need to creatively think through your use case and identify all the machine learning models you will build, the data that you will collect to train those models, the model architecture that you will use, and how you will evaluate those models. Let's continue with the Google Translate system of models example that we have going. Here is a web user interface. It starts with you typing in a search query. Perhaps you type Google Translate. The first model figures out whether this Translate UI should be shown immediately or whether it should be shown a list of search results, which is the normal Google search results page. The advantage of this user interface is that I can quickly start typing the text I want to translate. I don't need another click to go to a dedicated website for Google Translate. Why do I say that it is a machine learning model that decides whether or not to show the Translate user interface? Because it's not as simple as a rule that says, if someone searches for Google Translate, show them this UI. Here, for example, I searched for translate a million reasons why to Spanish. And the machine learning model figured out my intent, pre-populated the text boxes, and made the appropriate menu selections so that I get the result I want, and I can quickly change the input text to get different variations. Turns out I don't even need the word translate to appear in my query. Here, all I had to say was the ugly duckling in German, and the in German was understood to mean I wanted to get translation. So whether to bring up the translation user interface in response to a search involves machine learning, and it involves understanding unstructured text. So back to my original query, where I simply typed Google Translate. The Translate UI comes up, but it doesn't know whether I want to translate German to English or from English to German or whether I want something else. but I start to type some text into the first window, and the second machine learning model kicks in. It detects that I'm typing English. Look at the model marked 2 in the red circle. That second ML model is a classification model. Given some text, the model will predict what language it's in. Of course, it doesn't help when it comes to determining what language I want to convert to. So I go on and select Tamil, the language I speak at home and the only other language I know reasonably well. And the translation machine learning model kicks in and does the English to Tamil translation model. This, model number 3, shown in the yellow circle. This is, of course, a core use case. And if I had asked you, what ML model do you think you need to build for translation? This is the model you would have identified. But there are still a few more machine learning models in this user journey. The fourth model, see the green circle, would be used if I clicked on the speaker icon. Imagine that I don't know Tamil. I know only English. And I'm in a little Tamil village and I need to ask how to get to the railway station. Sure, it's useful the English gets translated to Tamil, but imagine how much more useful it would be if I can click on the speaker button and have the Tamil be spoken aloud. That way, whoever I'm asking doesn't have to read from my phone. So the fourth machine learning model is a text-to-speech model. But maybe it's loud on the street. It might be helpful for me to read the Tamil text out loud. Except, what are all these squiggly things? If I don't know Tamil, it's likely I don't know how to read Tamil alphabet. So the fifth model, the fifth machine learning model, see the blue circle, is a Tamil text to phonetic model, so that I can read the Tamil out loud if I need to. The sixth model that I see on this page is back to the original query itself. I don't need to be typing while standing on a street corner somewhere wondering where the railway station is. I can speak into the phone and get the translation service going. The sixth model that I see in this user journey is the ability to search via voice, to ask for translate XYZ to Tamil. I probably missed a few more, but I'm sure you get the idea. When you build machine learning models, don't just think about the core ML model, think about the entire user journey and plan for all the machine learning models that you will need to build.